Page 18 of quadratics. Number 12. Two trains travel a 160-kilometer track each day. Express train travels 10 kilometers an hour faster and takes 30 minutes less time than the normal train. Find the speed of the express. One thing we need to be careful about here is that here it gives us the time in two different units. It gives us per hour, and then it also gives us 30 minutes less. So it gives us minutes and hours. Let's try to use just one of the two. It's kind of complicated to change 10 kilometers an hour into minutes, so let's just change the minutes into hours. So let's call the 30 minutes, instead of saying 30 minutes, we'll say 0.5 hours. Okay? So we're going to compare the normal train with the express train. The normal train travels at v velocity, and it goes a certain distance over a certain time. The only thing we know here is the distance. The distance is 160 kilometers, so we'll put that there. What about the express train? The express train travels 10 kilometers an hour faster than the normal train. So it's v plus 10. It goes 160 kilometers also, and the time is 30 minutes less, so it's t minus 0.5. And then, let's see, we want to make this into a quadratic equation with only one variable, and we have two, but we do have a way to change those two variables into one because we have a relationship between the two variables. So let's substitute 160 divided by t in for the v here, and then we're going to get rid of one of the variables. Okay, now we could multiply both sides by t minus 0.5. And then these cancel out. And then we can also multiply both sides by t to get rid of this t here. So we multiply by t here, multiply by t here, and then let's see, we'll end up with t minus 0.5, and then we'll have 160 plus 10t, because we multiply t times this one, multiply t times this one, and we get that. That's equal to 160t. Let's reverse the order of these two because we're used to having the t first. So t minus 0.5 times 10t plus 160 equals 160t. Now we need to combine this term with the rest, so we need to multiply this out. We can't leave it factored. So we're going to do FOIL. 10t times t is 10t squared. Negative 0.5 times 160 is negative 80. Let's multiply the outside terms. T times 160 is plus 160t. The inside terms is negative 0.5 times 10t, which is negative 5t, equals 160t. And what do you know? There's a 160t here, there's a 160t here. We can get rid of those, and we're left with 0 on this side. And then on this side, we have 10t squared minus 5t minus 80. And if we find the solutions, what t makes this equal to 0, then we're going to find the time that the normal train takes to go 160 kilometers. And let's use the, you would just use the quadratic formula to find this. If you're allowed to use your calculator on this step, you can use an application called polysmlt. In polysmlt, you just say polyroot finder, order 2, because it's a second degree equation. It's like squared. And you're going to just type in the coefficients a, b, and c. A is 10, b is negative 5, c is negative 80. I've already typed these in. Okay, and then you just press solve, and it'll do the quadratic formula for you, and it gives you the two possible solutions, which are t equals 3.09 hours, and the other solution is negative 2.59 hours. But negative time in this case does not make sense. So we're going to use this solution here. Once we know this solution, we can figure out the velocity, because 160 divided by 3.09 is the velocity of the normal train. So let's get out of polysmlt, and we are going to take 160 and divide it by 3.09 hours, and it gives us a velocity of 51.78 or 51.8 kilometers an hour. And then remember that the express train goes faster than that. In fact, it goes 10 kilometers faster than that. So you just add 10 to that, and that'll give you the velocity of the express train. It'll be 61.8 kilometers per hour. And that is exactly what they asked for. They asked for the speed of the express train. Okay? And that's what we're going to do for this page.